How's it going, everyone? Javier Gonzalez again. And in today's video, we're going to continue to look at the React performance, which is a course taught by Steve Kinney, the head front-end engineer at Temporal, a durable execution platform. So you can think of this some sort of a orchestration systems, which is an open source tool to cover specific business use case. That actually is a very interesting tool. The goal of this course is to look at how can we write performance React components and therefore React application. So, because now we're going to focus is briefly of the course structure here, specifically walk through this introduction, then the React rendering, straightforward, very quickly. So then we can now jump into what really matters for this video, which is extracting the state logic into a reducer, passing data deeply with context, and then scaling up with reducer and context. Why is this? Because as a way to understand and have much more clarity, especially of how React works, it is important to me to recap and to describe how do we get here with React by looking at the learn sections on the React docs, describing the UI, and then adding interactivity, and then managing the states, and then escape the hatches, as a way to understand now how this story originates, and ultimately, how do we get here. So once we understand that, or I understand that, you will embrace complexity. I will embrace complexity. So, well, because the point of this course is to help developers to understand how React works. Is for those developers that want to know how React works in a more practical sense. Also, look at how can we now build a toolset to identify is React performance issues, and then come up with some solutions, with some best practice, especially, for example, the best practice that we're going to look is something that is going to apply to small and also big applications. So this is pretty much like pulling off the threads in a big knot, and when you apply the techniques over and over and over and over, then you solve that. So the value proposition of React performance is, well, which is something that you can apply to your life, is not doing things faster than doing things, specifically priority things, okay? So not doing things that are not priority is way faster than doing it, okay? And there's some corollaries to that. So doing things later on is way more faster than doing it now. So with that introduction, okay, where we're going to look at what will be is this tool set, okay, that when we encounter a React performance issue, we say, all right, this is a particular roadmap that we would like to take. First, look at the lifesite website if they deploy on production, if they have the production flag activated. Also, look at now how the component hierarchy and state, you can start from there, right? Especially if this is a performance, if this is a performance issue. Also, take a look at what is the memoizing strategy that this application is using as a way to prevent call these components during rendering, okay? So if you put that at the bottom, at the top of your, or higher in your tree, then you sometimes will have some sort of issues or problems with that. So here we're going to see how can we solve those problems. And also is now how can we now load things using the suspend API later, all right? And ultimately, if you're in a pickle, if you're in trouble, well, see how you can use the transition API. So now, as a way to understand now how React works, and then dive deep into more practical approach of the React performance, okay? First, we need to make a quick recap of what React is, okay? So, after all, React allows us to define its UI set interface, which we can define this using this components function. We also look at how can we import and export functions. How can we now use JSX as a way to connect JavaScript to the HTML DOM? How can we render conditional components? And what is the difference when you returning is different JSX? Because after all, this is what JSX element. This is what these functions return. This UI return. Something that we're gonna also talk about here. Also look at how can we now rendering list of elements, and what is important to put a key here as a way to notify React, hey, please keep track of this, maintain an order here. And also how now it's important to create our components in a pure way, because it will allow us to run in any JavaScript environment, not only in the browser but in the server where workers. It also can now give us the ability to catch that data by memoizing the props, or by saying, hey, please, I don't want you to run this again. React, I don't want you to re-render this again. And the other is that when we're passing data through the tree render, or to the render tree, how you can now safely stop the execution of that phase, so we can do that in a safe manner. So this render tree, which is how now React see these components, and this is now part of the computer science, which is a data structure, and a data structure is just a place or how you can organize your data that actually is fit for certain situations. A good example is that you have a fridge, you have a backpack. On your fridge, you usually store is frozen stuff, right? Let's say fish or ice cream, okay? But in your backpack, you hold your laptop or tablet, pencils. You can switch where you want to store things, but they are not designed for that. So that's exactly the role of the data structure. So they are good at what they're doing to cover a specific case. It usually is to improve is the access time, insertion, deletion, and reorder element. And then you also have is the traversal. So this is the tree data structure, okay? That now once you understand, you can see how now the components is organized in React as a way to understand how we want to impact the performance, and also how the data flows go through, as well as the tree dependency, which is now how all of this, the utility function that you pass to each one of these components, now can you reduce them or find ways to actually minimize the bundle. Why is that? Because the bigger your bundle that you are importing in these components as utility functions, the more heavy is or the more bloated your code it'll be when you have to send that. Despite that you set to production, it'll be it could be a bloated code that you send to the client. So if your client is on 2G connectivity areas or 3G areas, that might be a problem. a performance problem, because now the user has to wait for the content to be loaded. So this is now where it comes these advanced techniques like code splitting and server-side render. Again, this go beyond the scope of this. It's important to understand them. And the other is now, once we understand this, the render tree, the tree depths, how can we now connect that? How can we add interactivity to that? So, thanks to our handlers, we can actually connect the JavaScript side to the template, all right? And we can get that data. But especially when you're developing this UI, it's much more important or interesting to show something to the user, to show some data to the users. And that is when we have now state, a components memory, where this allows us is to remember things, okay? And I really like the term that, to remember things that are relevant for this component. And you can set anytime you want us to update the state, or when you want to update the state, you set that. So now React expose you this useState, where you can tell, hey React, I want you to now store the value, and I want you to now provide me the value, and this is the setter function. So this setter function, which can accept is a primitive or a function, okay? When you do that, it'll set a trigger. So you're going to put those state updates inside of your event handler. So in this way, now when you trigger a render, React will evaluate that event handlers, okay, and it will save the state will be safe, or React keep your state fixed during the execution of the event handlers when you are setting your update, okay? So what is this render thing? This is the different mechanism or different phases that React actually go through as a way to say, all right, when I detect and state updates, when you want to modify or pass update your state, okay, this memory components, when you want to update what you remember, it is time to actually now pass through these different assembly line phases, okay? First is the render, first is the trigger, where you say, hey, this actually, I detect a state update. And that is, it can be at the initial render, or it can be caused by a component state updates, or any of it is patterned. This is something important to remember. Anytime when you are writing these React components, it's like, oh, okay, you know, especially when you are going to set, you're going to update any state. Then React say, okay, now that I detect this state update, the trigger phase, let me actually render. And this is just the way of React call your components. So by calling your components, all right, it can be at the initial render when you mount that, when you mount your components, or it can be during a renders. So React will call the component that causes state updates, okay? And the output of that, which is a GSX, it will take a look and say, all right, do we have any more? Do we have React components here? Yes. All right. So let me now call those components. All right. And the output, which is a GSX element, say, do we still continue to have React components? Yes. And they're going to do that in a recursive way until exhaustion, until there is no more element. Now, once we understand that, and anytime React call your components actually keep track, which is something interesting here, right? So during a re-render, React will calculate their properties, if any have changed since the previous render. Okay, hey, any of these properties, props or state has changed, all right, it's gonna keep track of that. I'm gonna calculate, React will calculate which of the property, if any, have changed since the previous render. And then once you compute that, all right, now it'll going to commit those changes, the next phase, to apply the necessary down updates, as long as they're different between renders, between these React components, and then apply those to the DOM. So when the browser detects those DOM updates, which is the epilogue, he going to render those components, or he will paint that as a way to not cause confusion here. All right, so once we look at how this rendering mechanism is doing for us, okay, and how now when you actually setting a state, how important to think of them as a snapshot of your application, especially when you are setting the state, and when you're setting the state's values are the state value change in the next render. So when you are now in an event handler, when a React is evaluating is in a React handler here. So when you trigger and state updates, you are sending the state to React. React takes that, now pass through the rendering mechanism by saying, hey, let me now evaluate this component. And you're going to do that with the state that you provide. So you're going to see those change in the next render. In other words, during the commit phase, and when that's done, the browser repaints the paint. So this is something interesting, this finicky detail about that, because it will give you now an understanding of how now we're passing state, how states are working behind the scenes, and which of course it leads to a lot of confusion, especially when you're updating object states or array or when you're updating object states or Jesus when you update object in a state, array in a state, and how now you should always return is a new state from that. You should not return is a reference for that. Why is that? As a way to make your state pure without side effect, which means that you're returning is a new instance of this. And if you want to keep up your update state logic maintainable, we use things like or consistent. We use things like immer, all right? That makes a lot of sense. It makes a lot of sense. And also, another source of bugs is when you don't have is a structure of how you're going to define your state in your components. Not to mention, if you don't have a consistent way to update state in the component, or when you don't know how to pass data to different components. So that's when we are looking now at the managing state, and how this, by recognizing that, how important it is to look at how can we now define our state structure, as well as keep the state logic, keep the state update logic is maintainable, and also how you can send components down there or to distant child component. So now, all right, with this, first we'll look at, all right, how can we now react into input states, and before that, or yeah, how can we react to input states, and how important is to look at what is the mental model that React gives us as a way to describe UI elements, okay, in a declarative way, because before React you can do that in the most imperative way. So you tell exactly what to do and how to do that. So you pick the elements of the document, get element by ID, and then you say, hey, let me get this element and put it into a, let me remove that element from the DOM. So for example, when I click here, okay, so a good example of this is, hey, I would like to create a password input. Okay, so when I hit the button, I want to change is the type of the input as a password or as an input, right? To make it visible. All right. So this is now, okay, this is now how you can do that. Because this imperative way of doing this is pretty much like you getting into a taxi cab and you tell the driver, hey, go on, drive. Here, turn up the light. No, but we can't do that. No, I don't know. I don't care. Turn off the light. Find a way to turn off the light here. So perhaps you have to do another round about it to do that. And then on the next two street, turn on the right, and then turn up the light, turn on the left. It's like, hey, what is this? Is some sort of, are you gonna rape me? Anyway, so the idea here is that the driver is nervous because he needs to also receive all of your instructions one at a time. And also when it comes to creating now scalable applications, this kind of things becomes quite hard to maintain, or at least this is from React docs, and also to my experience, because you have a lot of this code that tells you how to do this kind of thing. And this is one of the reasons why, for example, in the JavaScript now they have moved to a more declarative approach. So for example, with utility functions, like on the array, for example, like or on the string, like match, or start with, start end, you know, all of these common operations now they are giving us for us, so we can speed up the process of developing and actually satisfy the customer needs, as well as our shareholders, and also, okay, by looking at this, by understanding the reason why we are using this declarative approach, this React mental model, okay, of defining UI, which is first identify the different visual state of your app, then determine what trigger those visual state, define the state in memory using useState, okay, eliminate any non-essential states, and then connect to the event, or to connect handlers to set the event or to set the states. This process is something that is mechanical. This is a mechanical process here, which are combining is the UI development, okay, from designers, okay, and when it comes to actually is managing our states, okay, we need to define a state structure as a way to have consistency. in being memory efficient. So organize your states per groups, avoid any contradiction state, avoid any redundant state, which means, hey, can I get this data from any of, for example, the props or any other state, okay? Instead of actually create that. Avoid duplicate states because they are hard to keep track. And also avoid deeply nested objects. These recommendations, which is known as normalization, which is something that database engineer knows, now allow us is to say, all right, now that we have this declarative way of writing UI from the designers, okay, identify the different visual states, determine what trigger those state updates, set the state in memory using or determine the state using the useState, eliminating unessential states, and connect the event handler to set the state. All of this, all right? Now when you're, this is not to describe as the UI, and when you're going to combine is the data layer or memory, where we're going to remember things, is this state structure. This combination to me was quite fantastic because at the end of the day, most of us, in what drives this innovation is the combination of things that you shouldn't supposed to combine, or that we haven't conceived that we need to combine. And I say need because, quite frankly, that's something that we will gravitate towards that when we are combining things that we didn't supposed to. And then you're gonna say, oh, okay, all right, now this is the value proposition of this. So, managing your state. It's also interesting that, especially when you have these UI selection patterns, do not use an object, instead use the index or an ID for that. And when you want to create multiple selections, use this as set for that. And I think that's quite interesting because when you're setting in, and to me it was like, what? To me it was like interesting because when you're setting now this kind of thing, okay, as a way to now understand the previous sections, and then finally move to what is relevant in today's video, preserving and resetting state, okay? So I'm gonna make a quick recap of how we want to do this. We implement multiple selections, okay? So for do that, we need to define is what data structure we would like to actually keep track of all of these selected, right? An ID is the way of how we can do this, all right, in our components. So by now creating these selected IDs, okay, these selected IDs as a data structure, which is new map here, new set, sorry, because maps hold is unique keys, set holds is unique values, which is great. So when we're adding element to this, if this value already exists, it's going to create, it won't create is a new record of that. It's like, hey, I already got this. Okay. So maps allows us to hold not only primitive, but also object reference here. Okay. Both for objects and primitives. Jesus. Set. Exactly. Whether primitive or object reference. See? So primitives are string, booleans, big int, symbol, undefined, null, and there, yeah. Exactly. So 3 and 6. Yeah, I mean, so is string number. This is the primitive, okay, the atomic here. So you have string number, big int, which is recently added to this as a way to have much more precision. Big int, boolean, symbol as a way to uniquely identify this. Undefined null, right? So this primitive is something that now the set can store, okay, as a way to say, hey, this is unique, and let's go to check that out. So if we say cons here, because this can, the idea here is that using this set or maps, their lookup times is, you can think of this as O1, constant, which means is that no matter how big this collection are, if you're gonna access to one of these elements, you're gonna get it. A real life example is that no matter how many ice cream you have stored in your fridge, okay, you will get what you want. So I wouldn't recommend use. Yeah, I won't use that kind of example. No. So protein. I prefer to go with protein. Okay. So if you have in your kitchen, exactly. If you have in your kitchen, in your pantry. Oh, okay. Kitchen pantry. Okay, if you have in your kitchen pantry a lot of protein, okay, you can now, when you see that, you know what you want. You can get that quickly. So no matter your kitchen pantry growth, as well as your collection of different proteins and BCAA and that kind of thing, it's like you are always going to get that. So you also going to find things quickly, all right? So not only find them, okay, but also remove them or add into that, right? You're gonna do that fast. So this that instruction, for example, here that actually can accept, okay, is so sets are set objects are collections of values. Values may occur only once, and because here set like objects, all set composition method require this to be an actual set instant, but the arguments just need to be set like. A set like object is an object that provides the following: size, has, and keys. All right, method that return an iterator. Method that return an iterator. Again, this is a set like object is an object that provides the following. Okay, a set that object, size, has, and the keys. For example, maps are set like because they also have their size, has, and keys. So many set composition. Okay. All set composition method require that this to be an actual set of the instant. To be an actual set of the instance, which means they need to have is this. Okay. One, two, and 4. So your adding is this, the union here. The set like protocol involve the key method instead of the iterator to produce elements. This is to make maps valid set-like objects, because for maps, the iterator produces entry but has method takes key. Arrays are not set-like because they don't have a has methods and a property size, and their keys method. Okay, this is interesting. Set-like objects. If this object contains is the size, has, and keys, makes sense. And the key is an iterator, and an iterator is a protocol that allows us to have access in a sequence of elements by first defining is the behavior, the iterative behavior that this object will have when you use some looping syntax for in, okay? And you can also create your own iterators, okay? Using is the prototype by creating a function from that, and then the reason of using is the iterator, which is a Python pattern, is just as a way to make it much more simpler when it comes to work with large collections of data. Why this is important? Because that's exactly what the vast majority of the time we're gonna do. Handling is large collection of data. So instead of actually us manually to say, hey, we want to now iterate through these collections and I want to do this like so, okay, in an imperative way, which is there is nothing wrong about it. Now with this iterable or this iterator thing, or this iterative protocol, which is made of the iterable part, which is where you define is the custom iterable behavior, okay, and the iterator, which is now the sequence of data that is going to produce by following is a particular protocol. By exposing is the next object, by exposing an object, it contains the next, and instead of that, it has the value, and then it's done. As a way to say, hey, do we reach the end of this array or this data structure or this iterable? Okay, so that's quite interesting. Again, it makes a lot of sense. It makes a lot of sense. So if you want to now apply some methods to this, you need to make those sets you need to make them a set-like object, which is they must contain size, has, and key. So when you create a new map here, for example, you say new map, all right? That unlike set, maps are here, like map is this hash-like thing, okay? What you can now store is the value and the property. So you can see here now, map has keys and size. So it is compatible to this. So here you can say, hey, I want you to now create is this map by passing is initially an object, okay, because any value here, object hold key value pairs, and remember the original insertion order of the key. Any value, both objects and primitive value, may be used as either a key or a value. That's right. And one of the great things of the key is that when you want to update your object, you can say, okay, this is the way how you can do this. When you want to update a key for that. Exactly. You can do this But the idea here is that map like objects here. Exactly. Map like object. So the construction here, it takes now an iterable. So arrays now are kind of iterables. An array of ordered iterables whose elements are key value. For example, arrays with two elements such as 1 and 2, each key value pair it is added to the map. So, but they now accept is a special type of this. You can pass this an iterable. You know, all of these concepts are stacking each other's. Map can only be constructed with a new, attempting to call it with a new throw type error. So, because now we can pass this an iterable, all right? Because now we can pass this an iterable. Okay, you want to know examples of iterable? User-defined iterable. So, for example, generators are a special type of generators, of iterators, right? Because the return is because you can modify is the custom iterated behavior, which is an iterable, and then the iterator protocol is that it returns this format, this protocol, which is this object that contains the next that it return this next function that contains this object with the value and the DOM. So this is quite interesting, you know, as a way to understanding a little bit more. Overriding built-in iterables. You know, if you want to look at more, for example, iterators, okay, like iterator here, the following are built-in JavaScript iterators. So arrays, values, keys, entries, type array, string iterator returned by string.prototype iterator, as a way to say, hey, we're going to implement now is the iterator. Map iterator returned by values, keys, and entries. The set iterator returned by the set, exactly. Regular expressions. Iterators returned by prototype.match and match all. Interesting. Generators are a special type of iterators. The segment iterator returned by the iterator, that's right, an iterator helper returned by the helpers. But as you can see here, this iterator, like so, where you can say, hey, name deposit.values, which is an iterator. So you're going now to have is these values, all right. Name deposit of the values, and by doing is a spread operator, I want you to now put it all of this values and give me is now the total deposit here. Okay, so okay, so what you're doing here is now, okay, this is the iterable. And with this syntax, I want you to know is to walk through all of these elements here. It's like walk through all of this. So this is a looping syntax here that is doing. That's quite interesting. That's quite interesting. Spread syntax. Exactly. The spread syntax allows an iterable, such an array or a string, to be expanded in places where 0, oh my god. Okay. In an object literal, the spread syntax enumerate the property. of an object and adds the key value pair to the object being created. So it creates now this as a way to say, hey, now all of these elements will correspond to that, especially in the spread syntax. Exactly, because here it can set an iterable object. Interesting. So spread syntax can be used when all elements from an object or an array need to be included in the new array or object, or should be applied one by one in a function called argument list. There are three distinct places that accept the spread syntax: in the functions, in the array, but as long as that is an iterable, okay, so we to expand this, and object literals. Only iterable values like array and string can be spread in array literals. Exactly. An argument list. Many objects are not iterable, including all plain objects. That lack of symbol.iterator method. On the other hand, spreading in object literal enumerates. Okay. So only iterable values in this array and string can be spread in array literal. Okay. But on the other hand, you can now spread or spreading object literals to own property here. You say, hey, that's gonna match is this zero key, that kind of thing. You can also see the true, a test. Okay, if this element is an iterable, you're going to actually assign this in an object. Interesting. As a key value pair. That's quite interesting. That's very, very interesting. But again, this is not what we signed for. Okay? This is not what we signed for. Copying an array like this. Because you can use expression to make a shallow copy of this. Because that expects that this is an iterator. Is this an iterable object? Alright, it can be an array, it can be a string, and it can do that instead of the arrays. But you can do that in objects, okay? But in objects, you can now spread is iterators. So for example, let's going to create our map here, where this is supposed to accept is iterables with the following shape. Like, it's gonna put here is the key, right? Key value here. Key. You can say foods, all right? And here we can accept is an array of this. So foods. Okay, so apple. Apples, bananas, mango, but I want to put this in plural. Banana, apple. Okay, apple, banana, mango. Okay, and here we got is, let's say, shoes. Yeah, shoes. Say, hey, tennis, gym, casual. All right. So here is now accepting is this iterable. All right. So if you want for some reason spread this iterator in an object, which is something you can do, for example, comes a new object here, you can say, hey, I want you to now spread the operator, which is, hey, I will go through each one of those elements and append them to this object, right? Spread syntax can be used when all elements from an object or array needed to be included in the new array or object. Exactly. Or should be applied one by one in a function called argument list. And there are three distinct in place. So if you want to now pass this to a new object as a way to create a new object, because the spread iterator, what it's doing is like, let me now exactly, so let me now go through this. Okay, let me now go through this iterable collection and add that to the object here, which is, hey, this is the foot, that's an array. Hey, this is shoe, that's an array. You can say, hey, spread now, and you do is shallow copies. So when you take a look now at this new object, what will be the shape of this you think it will look like? That is, you have is the object, all right? Oh, no, because maps are not iterators. Because maps are not iterables. Exactly. Maps are not iterables. So what we can do is to return is an iterable, which means we say, okay, and now give me is the entries. And when I take a look now at the object 1, we're gonna receive is this empty object. That's interesting. Entries, exactly. Entries method of math return a new map iterator. Okay, where it contains the value, key value pair. Yep. And yep, that's right. New map entries. New map entries. Okay. Why not? Let's go to define this. Let. Why not? That's quite interesting. I don't receiving that, even though that I'm doing the spread operator here. You know, in the spread syntax here. Okay. What about you say values here? Oh, of course. Okay, that's quite interesting. Well, what is the value of that? Is this one? Oh, it's because I didn't define that properly. All right, all right. I think that was quite revealing. I create this map wrong. Definition of the map was wrong because I need to actually is define this in an array. Okay, say you map 1. And here, when you say okay, new map 1 of the entries, you continually have that. That's interesting. Oh my god. This. Yeah. I defined this map wrong. This must be here. And I think I'm following is the right structure, right? Especially in the map constructor. 1, 2, and then separate for that. Factor with the key and values. Oh, but can you have multiple keys and values? Right, can you have multiple keys and values? Or unless the structure is more like this. You know what I mean? This is the structure here. And then when you say here, okay, no, this is not this. Okay. Okay. That's quite interesting. So if I want to define this more nested object like this, can I do that? No? Well, I am assuming that exactly. That's what happened. I'm assuming that is this shape. I'm assuming that this is the shape here. You know, I'm assuming that this is the shape. Right? Size 2, you got entries, food, and shoes. Right? So, if I want to make this new map 3, that's quite interesting. That's quite interesting. Even though that this is an iterator. Even though that this is an iterator. Okay. Anyway. So by having a state and say new map add food. So this method is not accepted yet. I mean it's set. Okay. Entries for each get, has, and set values. Exactly, the key and the value. And the value can be any, exactly. The value can be any JavaScript primitive or object. So that's quite interesting. That's quite interesting. Because it's set, okay. And then you say, okay, I want you to now add this. choose. Okay, and then this is the data from this. Okay, of course, here, and when I want to actually spread that, here on the entries, it say this is like it's quite interesting. It's quite interesting. Values. New map 3.values. Exactly, it's a map of iterator. So even though that despite the spread iterator actually get this, it's not actually is spreading that. But because those iterator MDN iterator objects. Exactly. Describe the following are built in JavaScript iterators. Map.values. Exactly. And the spread syntax. But with the express syntax, conditionally adding values to an array. Holy shit. Because it's this. That is quite interesting. That is quite interesting. So sets are not able to spread that. You can say, hey, is this a condition exists? Well, it's because you must return is the Yep, but for some reason it's like no. Yeah, it's like no. That's to me is quite interesting. Yeah, it's like no. But when I call this, so for example, if I say for cons key and value of an iterable, I want you to know console.log is the key followed by the value. And yeah, I get it. It's a food, that's an array. But that's quite interesting. It's like, But when I want to use the spread operator, it's like, especially in an object, it's like, That's quite interesting. In an array, it's doing that. That's interesting. But in object, it's like, okay, that's your behavior. Okay, but for example, if our map2, okay, contain is this, say, hey, this is food one, say apple. All right, there's a way to say, hey, this is set food and apple here. And umap is 2 is not defined. What about, let me create now is any object here is a new map here for, that is a new map. That's a way to call the constructor here. And then you say, hey, new map 4, I want you to add this, as well as this. But food 2 is now banana, right? And when I want to spread that, okay, because it's doing a shallow copy. It's because it's doing a shallow copy here. Okay, no problem. No problem. Okay. Anyway, so now that we navigate through all of this, okay, as a way to understand this particular case, and when it comes to actually share state between components, as a way to say, all right, when you want a state share between different components, you leave state up. All right, and the idea here is that this is something common, sharing states across components. So if you have several of these components that you want to share, so you remove the state from those components, you now add the props, or you hard-coded the props in from the parent that you want to pass down. Okay, so you remove the state from the child, you pass hard-coded data to common pattern, and then you put the state in the parent component. All of this is now starting to introduce the concept of single source of truth, which is something that Redux actually is doing. Okay. So for each unique piece of state, you will choose the components that owns it. Okay. So this principle is known as having a single source of truth. And the principle of having a single source of truth is that for each unique piece of state, you choose the components that owns it. This is part of the rule here. Okay, for each piece of a state, you choose the component that owns it. Okay, so okay, and now this is now in the React way the source of truth. The source of truth. Okay, which component? Which state will own the or which components will own the state? Or for unique state or for unique piece of states, you will choose which components owns it. I think this is more actually quite straightforward. So yeah, totally. That makes a lot of sense. Yeah. That makes a lot of sense. Exactly. So for each unique piece of state, you will choose who components owns it, and this is a rule that now is going to apply when you want to actually define where this component will live. When you want to now trigger state updates as a way to now pass data to distinct components, but for that you need to choose for each unique piece of state which components owns it. Okay. So yeah, that's actually is quite interesting here. So for example, we now a very single. If you want to sync input, all right, this is exactly what we do here. Hey, this is now. So we remove this state from below, from this child components, and we now hard-coded the data here for the text, which is now passing as a text here to this. The text will be now something that is hard-coded, but since this is quite basic, we don't need to do that. We're just going to pass and then add the state and do that. So now these inputs are sync. Exact. Oh my god. Exactly. So you are not handling this state here. Okay. and in fact, and when this change, you don't want to actually handle this because you're going to receive is those from that. And it's here when you're gonna say, all right, when I want you to run this, when now on this input that most exposed is the on click, okay, event, which is here, we can say is handle here, handle change, with handle change, and handle change with handle change. All right, now when we receive this handle change, we want is to now trigger this the on click on input. So we have now then sync. But the idea here is to look at now for each state of, as you want to share states, so for each piece of states, you will decide which components owns it. Okay, so this is the component who owns this share state. Okay, it's a way to know not only this component can have access to all of this. And this is something interesting because now when you define whose component owns this, you can say, all right, in this example, the search bar has its own query here. State control detects input and it is pattern filterable list. Use a filter item food query function to filter the list according to the search query. To test your change, verify that typing S into the input filter down the list to sushi and cheese kebab and dimsum. Know that the filter items is already implementing and important, so you don't need to write it yourself. So because we now want this to share this state across components, okay, we identify which component we want to own this piece of state, okay, which is the pattern component, which is here. So we remove the state here. All right, so we remove the state. So we remove the state here. We hard-coded now is the data passed down to the child from the parent, and in this case is the query, okay, as well as handle change, okay. You can say on handle, on change, okay. And here and on change, which is where it caused the event to trigger, I want you to now run this function, okay. That here is when I'm going to detect that. How so? By listening to the on change event or function here. That now we're going to say, all right, let now handle change, okay, handle change, and here we're going to receive is the event from the child component, and I want you to now update the query here by saying I want to set the query here with the value that we get from there, pretty much, and append that listener to the on change. So far so good. Now when we set this, when we trigger this, we detect that change here. We also need to say, all right, because this is an arrow function. we need to say, all right, good. Now we need to also is to update is the foods. Okay, we need to find a way to update the foods, because we don't want to mutate the food. In fact, we want to create a new state of foods. Okay, we can say, okay, so foods here, say foods, all right, or we can say selected foods, or filter food. Exactly, filter food. Or as a way to reuse this, is say food will be is the as all foods. Okay, as all food. Food, then you say set foods. Food as all food. That's right. And all right, now, so instead of actually doing this, okay, can we get this data without actually doing this? You know, in other words, is that I don't want to duplicate this state here. Can we get this information here? Can we get this information here and say anytime you now trigger this, I want you to now update the foods. Okay, or create a new state from the foods, say as all foods. Okay, that has a reference to them, and then going to filter that. So why is this? Which will be equal to all foods dot filter base, okay, based on this condition. You have the food, and if that food, or you can use is the filter items here, like this one. Okay, much better. So filter items, you're gonna pass is the all foods, followed by the query, right? So when you change here, so when this input, when you set the state here, okay, by calling the, when you set this state here, by calling is the handler that activates that setter, which is in the filterable list, okay? Now React will say, okay, who's causing this rendering? Okay, it's this component. All right. So now we're gonna take a snapshot of this, okay, where at that moment it'll be, for example, S. Okay, it's going to evaluate is the entire function with this state, okay, which is query, and then food, hey, filter items. Now you got now this updated state, and then it's going to render is the GSX. It's going to generate is the GSX output, and if this is and if this contains more React components, which is search bar, it's a all right. We also want this to pass is the query here, okay, as a way to show the query. So when we are running this, so here I want you to walk through this thing here pretty quickly. Okay, who actually is causing this set state updates? Okay, it comes from now an event here that it comes from the child component, which is here unchanged. All right, good. Now because this component is actually triggering this set up state, this set update. All right, now let me hold the value at that moment here, the state at that moment, and evaluate this function by saying, okay, what is query? Initially is empty. Okay, but now query is S because we received that event to trigger that. And then you're going to evaluate the food filtering item with query and going to get that array. That now when React evaluate this output from the GSX, from the React component, and say, do we have more components there? Yes, search bar and list item. Okay, so let me now call this component, okay, and evaluate them. If any of these component states are, or if any of the GSX are different, then I'm going to commit the phase. Then I go to the commit phase, which is I'm going to apply the necessary change to that. And you're going to do the same for the list item. Hey, is the list item that we're passing here, which of course is different, do we have any difference between rendering? Yes. All right. Now let me apply the necessary state updates or the necessary DOM updates, so you can now have let React upload. Let me walk through this. So what's going on here? Okay, when we are setting the query, React say, okay, whose component caused this? Filterable list. For the developer perspective is, okay, but what components trigger this state update? Or who is triggering this state update? Handle change. Where did handle change come from? Oh, it changed from the unchanged search bar, which is on the search bar is emitting this event from this input. Okay, so now this input here is being triggering. So now this input is this input event is actually triggering is on the pattern, the handle change to set the state. Okay, and when we're setting the state, it say, okay, React now say, let me hold the state here with this update value that you pass me, which is, let's going to assume that this is S, okay? And then I'm going to evaluate this entire function. Hey, what is query? Okay, it's a new state. Hey, what is foods? Okay, it's this, which is actually now we're going to pass this the query, which is S, as well as the food. And we're going to get, in our case, is all of the food filtering, right? Then I'm going to evaluate is the React component or the return by saying, hey, do we have more React components? Yes, we have. Yes, we have. Okay, search bar. What is search bar? Let me call this. And by calling is that I'm going to pass the query and I'm going to pass the handle and unchanged here. And runs this, okay, and say, hey, does this actually, do we have any more React components? No. Okay. And then it's also going to call is the list item. Okay. It's going to run this function, pass this data, and because the data changed, it say, hey, these components here, this CSS components is different from the previous rendering. If it is, okay, now runs it. So apply the necessary DOM update, which is the commit phase, and then now the browser detects those changes and render your component. Okay, so this must work. It's supposed to work by saying, okay, this is the query, good, an S, and it worked as expected, you know. But all of this is important to actually understand as a way to say, okay, what will happen here? And I think this is, yeah, this is a combination between technical communication and actually work. Okay, that is quite interesting. That is very, very powerful. So, on the next topic, because we're talking about the sharing states between components, and how now we are applying is what we have looked previously as a way to see how this thing is actually working. Okay, and when it comes to the preserving and resetting state, the state is tied to the position in the render tree. So in other words, is that you create a new instance here. So if you have sibling components, okay, React counts them as separate components. Okay, they're gonna count as, okay, preserving and resetting a state. Okay, so here is saying, hey, if you have elements in the same, if these components are sibling, okay, you're gonna render, they're gonna have its own state. Okay. However, for example, if they are however, if you and also if you remove an element at the same level, it actually restore is no, it actually is preserve the state. So for example, this, oh, it actually restores the state there because it removed the element from there. It makes sense. Okay, it makes sense. It creates a new state from that. So same components at the same position preserve state. Exactly. So the same components and the same position preserve the state. This is also interesting, especially if you're going to build this kind of application more and more. Okay? It preserves the state. But same components in the same position preserve the state. Different component at the same position, different components at the same positions reset the state. Okay. This is the rules. Okay, resetting state at the same position. Okay, resetting state at the same position. So how can you do this? Is by or rendering in different position or resetting the state with a key. Makes a lot of sense. Okay, but again, this is the rules. This is now more like rules. Okay, when preserving and resetting a state, you say, okay, that makes a lot of sense. What we go now to is, if you want to preserve the state, because states are preserved at the tree level, at the position in the render tree. Okay, the state are tied to the position of the render tree. Okay, so if you want to preserve the same state, so same component at the same component at the same level, preserve the state, even if you use conditional or not. Different components at different components at the same positions reset the state, because you are eliminating is that from the render tree. Okay, and different or preserving states, exactly, or different components, exactly, same components at the same level preserve the state, and the states are tied to the position of the render tree. So same components at the same position preserve state. Good. Different components at the same position reset state. Makes sense? So different components at the same position reset states. But where you want to resetting the state at the same position, because after all, same components at the same level preserve the state. But what is you want is to now resetting is the state of the same component. Okay, resetting the state at the same position. Well, you can use this. You can render this later on, or you can use this now a key for that. Because they are the same component. Exactly. Exactly. Different components at the same position reset states. But if you want to now reset states of the same component at the same position, you can render that on the in a different position. Okay. You render that in a different position, or you add a key to that. Rendering components in different position with different data. It reset the state, okay? Because otherwise, they'll actually is show you is the same. Or adding a key for that. So resetting a form with a key. Interesting. Preserving state for remove component. You may also use a different source in addition to React state. For example, you probably want a message to persist even if the user accidentally closed the page. To implement this, you could have a chat component initialize its state by reading from the local storage and save the draft there too. No matter which strategy you pick, a chat with Alice is conceptually distinct from chat with Bob. So it makes sense to give a key to the chat tree based on the current recipe. So in real chat app, you probably want to recover the input state when the user selects the previous recipe again. And there are a few ways to keep the state alive for a component that is no longer visible. You could render all chat inside of your all chat instead of just of the current one. You could leave the state up and hold the pending message for each recipe in the parent component, and this way, when the child's component gets removed, it doesn't matter because it is the parent key that keeps the important information, and this is the most common solution, exactly, as a way to say, hey, I want to preserve the state of this. Or you add a key and then you store the data on the local storage. React keeps state for as long as the same component is rendered on the same position. State is not kept in GSX stack. It is associated with tree position in which you put the GSX. You can force a subtree to reset its state by giving it a different key. You can force a subtree to reset its state by giving it a different key. And when you are putting this, you are now forcing is to render that. Don't next component definition or you will reset state by accident. So here is some of the challenge here. Fix disappearing input text. Okay, so we got is this, show hint, fix disappearing input text. Okay. However, pressing the button also accidentally reset the input. Show a message when you press the button. Show hint. High hint. Show hint. So pressing the button also accidentally reset the input. Why does this happen? Oh, because you have a different render tree. So one way to do that, okay, by preserving state here, is by saying, well, we would like now to show is this, is resetting the state, which is something that we don't want. So there are a couple of alternatives. Here we are resetting a state. We don't want to reset the state. What can we do? We can say we can get rid of this, okay, and only show this as needed. In other words, instead of doing this, okay, we want is to render this. All right. We would like is to render this, okay. But as long as the show hint, as long as the show hint exists, okay, I want now you to show is this. Exactly. Otherwise, this. So here you are going to now, I would like to set show, okay, we need to toggle this. We need to toggle the logic here. And then you got it, right? So actually we are not, is resetting is the state of a component. Because now, unlike before, we have different renderings. We have components at different positions in the render tree, which of course caused this behavior that React has. I'm going to reset this. Let me actually look at the solution here. That's right. Show hint, if show hint exists, I want you to do this. That's actually quite not necessary. There's too much logic here. You can actually only, toggle this. Less verbose, it's more intelligent, it's more reusable, Swap to form fields. Okay, this form lets you enter the first and last name. It also has a checkbox controlling which field goes first. Okay. When you take the checkbox, the last name field appear before the first name. Exactly. It almost works, but there is a bug. If you fill in the first name input and tick the checkbox, it clears that. Interesting is keeping the state at that position. The text will stay in the first input, which is now last name. Fix it so that the input text also move when you reverse the order. So again, perhaps we are rendering is different. We are rendering at the different. We are rendering components. We are rendering the same components at different position in the tree, right? So to prevent this, again, okay. So this is the checkbox. You want to show the checkbox. All right, so far so good. But instead of doing this, because actually you are anytime you see this kind of thing, it's like you're going to reset the field. You're gonna have some weird behavior here. You're gonna have some weird behaviors. So instead of doing this, let's going to say something like this. Hey, of course it's not gonna happen. They're gonna show it. That's right. What I want you to now is get rid of this. Okay. Okay. Who is actually taking control of the reverse? Okay. We are going to toggle this. Good. Good. Actually, we are getting is the value from this, which makes sense. Okay. And here we're gonna say, hey, because now we're using as a fragment here, we can say something like this. Hey, I want you to be this as a div. All right. Similar to the div. And because now I want this to show is in a reverse order. So one thing that I can do is to say, all right, I want to now render this. If the reverse is true, I want you to now render is this. Okay. I want you to now render is this. Okay. Which is first name and last name. However, if not, okay, however, if not, we can also use this. Hey, if this is reverse, I want you to now do this. Okay. If not, okay, then I want you to now is return is this, which is in this particular order. You can get too fancy about which order you want to show this kind of element, but again, do what really matters, bro. Reverse if this, fine. Okay. Oh, of course, of course, of course, of course, of course. Right, because they must have is the root element, and the same for this. The same for this. So if the reverse order is not, no, I think it's this exactly. If the reverse order is activated, last name and first name. Otherwise, you put this here. So what happened is that is because they are the same same components, preserve the state exactly. Sync components at the same level preserve the state. Say, hey, what? It should preserve the state. Exactly, same components at the same level, it should preserve the state. But they're using this fragment for that. But that's quite interesting. Why this is not working? Oh, because I need to wrap them into an... Okay. Okay, it's because it's... Okay, makes sense. Because I will need to include those checkbox there. Exactly, because different elements here, because you got different elements here. It's still preserving the state, which is quite interesting. Okay, it's not working as expected. Okay, this is more like the syntax way of doing this. So you can say is, well, if reverse exists, I want you to now is because I want to preserve the state. I want to now render this. Okay, I want you to now render this. If the reverse is false, otherwise, okay, I want you to now render is this. Jesus, it's because of this. So we got this, and we're gonna return this, okay, in this order. Otherwise, we're gonna return is this. This is not reverse. Exactly, not reverse and reverse. So here we are now preserving is the state. Here, it's not preserving the state. It's quite interesting. Okay. It's quite interesting. It's not that. It's because they're using its fragment for doing this. And otherwise, you want to return is this. And on the label here, exactly, it's like resetting the state, but I don't want you to reset the state. So same components at the same level, preserve the state. Same component at the same level, preserve the state. Same components at the same level, preserve the state, like this, but they are not the same components. That's one of the reasons why it doesn't preserve the state. So how can we now preserve the state? With a key, exactly. Yeah, because if you can do this here, because you're actually resetting a state because they're actually different components, which contain these different values. So one way to do this by using is a key here, and say, well, this is the first name, okay. And this is the first name as a way to indicate React, hey, I want you to preserve the state here. Makes a lot of sense. Holy moly, bro. Yep. So when you do this, it now preserves the state. Because you can also add a diff, and there's actually won't change this. Similar to this, or to rendering its fragment, and it will keep the state as well. But the problem is that we need to tell React, hey, we need to preserve the state here, and to do that is by, well, going into the or you preserve the state, or your components are the same, or your components are in the same position, okay, or you put a key here, okay. This is if you want to preserve the state, because otherwise it will reset the state. And this is something interesting, especially when you combine this with conditional rendering, okay. So React now, anytime you actually do that, it say, because I'm preserving is the state here at the render position, or at the position in the render tree. This is the way of how can I keep track everything here. That's interesting. So preserving and resetting the state, and then we looking here, extracting state logic into a reducer. Okay. Extracting state logic into a reducer, which is now how can we keep our state update logic maintainable, extracting state logic into a reducer. Okay. Component with many state updates spread across many event handlers can get overwhelming. Component with many state updates spread across many event handlers and can get overwhelming. For this case, you can consolidate all the state update logic outside of your component in a single function. Okay. So this state update logic will be in a single function here. So when we want to, for example, create is the Trello clone as a way to now move element from one to another place in the kind of thing. Which component needs to remember that? Okay. And also, which logic can we use? Yeah, which component? Okay, yeah. Which component? Which component? Yeah. So which component here? Yeah. So which component here? So which component is not only, so which component must remember is, which component must remember is the state. Okay. Interesting, very, very interesting. So which component needs to remember is how many elements do we have here, and also is that how we're going to handle this state update logic, because putting this in all of these event handlers, okay, can be overwhelming. So for this case, you can consolidate all the state update logic outside your components in a single function called a reducer. Which is a reducer, it's just a fancy function that takes the state and an action to generate a new bit of state out of this. But this is as a way to keep state update logic maintainable. So what a reducer function is, how to refactor useState and useReducer. How to refactor the useState to useReducer. When to use a reducer and how to write one well. Consolidating state logic here. As your component grows in complexity, it can get harder to see at a glance all the different ways in which a component state gets updated. Because as you can see here, it's like, well, we actually is now updating the state in different places. So handle add task, handle change task, handle delete that. Okay, and this actually works as expected. You want to select only one. And handle selected here as a way to set the task. And on the task list, what is the task list component? Okay, it's like irrelevant. Interesting. Okay. Each of its event handlers called setState in order to update the state. As this component grows, so does the amount of state logic sprinkling throughout it. To reduce this complexity and keep your component and keep all your logic in one easy to access place, You can move the state logic into a single function outside of your component called a reducer. Okay, so you want to reduce this complexity and keep all of your logic in one easy place to access as a way to maintain the update logic, as a way to keep your state updates logic maintainable. We have now this function that will handle that for us. So reducers are a different way to handle state. You can migrate from useState to useReducer in 3 steps. Move the setting state to dispatch actions. Write a reducer function, which is this function. Okay, move the settings state to dispatch. Okay, move the setting. Okay, move the setting state to dispatch action. Create this render function, which is a function that set in the state and a state and an action to generate a new bit of state, okay, and use the reducer from your component. So move the setting state to dispatch actions here. So your event handler currently specify what to do by setting a state, which is add a task, change a task, and delete task. Remove all of the state logic. Remove all of the state setting logic. Remove all of the state setting logic. What you left with are 3 event handlers, which is here. All of these actions, or all of this state, all of these handlers that trigger state updates. Exactly, because this is the way how to add in interactivity to this. Okay, managing a state with reducer is slightly different from directly setting the state. Instead of telling React what to do by setting a state, you specify what the user did by dispatching actions. Exactly, what the user did, or by dispatching actions from your event handlers. The state update logic will live elsewhere. The state update logic will live elsewhere. So instead of setting task via an event handler, you are dispatching and added change delete a task. This is more descriptive of the user intent. This is more descriptive of the user intent. Function handle add task dispatch. Exactly. So you're going to now is to, instead of setting the state, you're gonna dispatch is an action here. Type added, ID next ID, and text set as a way to now. Okay, and I get it. Why do we have now reducers here? As a way to now dispatch these actions. It makes a lot of sense. As a way to keep the state updates maintainable and readable. Okay, because now you're dispatching these actions that contains the proper action that you want. Okay, and it is very explicit, which is also that Redux, for example, actually implement that. Is that because we have all of these state updates there, okay, doing the thing that it has to do. We need to find a way to actually keep track of those state updates and have some sort of way to look at this. That's what the RTKey dev tool provides you. So handle add task, handle change task, and handle delete task. All right. So dispatch, and that's right. And the payload here, the ID and the text, the task and the ID. So the object you pass to dispatch is called an action. Okay, so the object that you're passing to dispatch is, okay, makes sense, an action. Action object is the type deleted ID task ID. It is a regular JavaScript object. You decide what to put in it, but generally it should contain the minimal information about what happened. What happened? And this is on pass. Hey, I dispatched this, and what happened? You will add the dispatch function itself in the letter step. An action object can have any shape. By convention, it is common to give it a string type that describes what happened and pass any information in other fields. The type is specific to a component, so in this example, either added or added text will be fine. Choose the name that say what happened. Okay. Jesus, I get it. Okay. Okay. That's right. Oh my God, yes. Okay.
Eso quedó muy bueno. comunicado con la casilla de mensajes de Movistar.
Che, te estaba llamando. Che, te estaba llamando era para saber si me podía acercar, aunque sea un ratico, a compartir con ustedes en el cumpleaños con tu mamá. Y más que todo era para comentarle el, que uno de los mejores regalos que ha hecho es criar a sus hijos. En especial a Joel, porque es el que conozco. Y que no, te estaba llamando era para ver si me podía acercar a donde iban a celebrar el cumpleaños con tu mamá y para felicitarla porque creo que el mejor regalo ha sido sus hijos. Y bueno, y como te conozco a ti, Joel, quería también quizás mencionarle, estando ella al frente, eh, el trabajo inmenso que ha hecho con sus hijos y bueno, en particular contigo, que es a quien te conozco, que no solamente tienes ética profesional, sino también es una ética que te ha llevado a desarrollar relaciones con otras personas, ¿no? Y que eso es súper importante, especialmente si quieres hacer negocios a largo plazo o quieres establecer relaciones sanas con tu pareja, futuras parejas, incluso hasta con tu familia, con amigos, colegas, ¿no? Que es parte también de la vida. Y la importancia justamente de reconocer eso, ¿no? Y de seguir echándole bola, seguir en el camino. No, era más que todo eso. Quería era por lo menos aprovechar esa oportunidad para decirle eso a tu mamá y a tu papá. Pero como justamente es el cumpleaños de tu mamá, bueno, aprovechar también esa oportunidad para comentárselo a ella y a tu papá si está ahí también. All right. Let's do it. So extracting state logic into a reducer. So what you want to define your type is to what happened. Okay. So the whole point of this is to, because you are handling is because you're setting the state updates inside of your event handlers. And if you create all of these event handlers, it has become very hard to keep track of which actually state are updating. So as a way to have a maintainable way to state updates, we use useReducer. And a reducer is just a function that allows us to have this maintainable and a reducer is just a function that accepts is the state and an action, and this actions is when you describe what happened. So this is now when you're using is a reducer instead of a useState, right? Which is another hooks. Move the setting state to dispatching actions. This is now consolidating state logic with a reducer. Step 1, move the setting state to dispatching actions like handle add task, handle change task, and handle delete task. Okay. So when these functions, you're going now is to dispatch. Where now dispatch is called an action. Hey, I want you to dispatch this action. I want you to set these actions. So move from setting state to dispatching action. Okay, this is now consolidating the state logic with a reducer. And then you write a reducer here, and because this dispatch takes an object with the type of what happened and then other relevant field, so write a reducer function here. And a reducer function is where you put your state logic. It takes two arguments, the current state and the action object that is returning the next state, which is your reducer function, right? Write a reducer function. Write now these functions that takes this input and generate is a new state of this. And this concept of reducer, let me see if that actually explain that. React will set the state to what you return from the reducer. Exactly. So React will set the state to what you return from the reducer. So now it's on the side of a reducer when we're telling to React, hey, I want you to set this state. Okay? But this is on the reducer way, under a more maintainable state update logic behavior. So to move your state setting logic from your event handler to a reducer function, in this example you will declare the current state task as the first argument, declare the action object as the second argument, return the next state from the reducer, which React will set the state to. Exactly. So declare the current state here in your reducer. Is that to move your state setting logic from your event handler to a reducer function? In this example, you will declare the current state task as the first argument. That's right. So in this particular case is the state. Okay, declare the current state as the first parameter, as the first argument. Declare the action object as the second argument, okay, which is the object that you pass to your reducer, okay. That's a way to dispatch this, okay. So when you dispatch this action, behind the scenes, So React will, okay, yeah, a reducer function where you put your state logic there. Yeah, because I want to know is how this actually works. Is the know-how. It is regular JavaScript object. You decide to what to put in, but generally it should contain the minimal information about what happened. You will add the dispatch function itself in the later step. Step 2, write a reducer function. A reducer function is where you put your state logic. It takes two arguments. Again, I know this is where you put your state logic, but again, let me continue. Okay, let's continue read this. React will set the state to what you return from the reducer. Exactly. So you're gonna take that and say, oh, now I'm going to update is the proper state with this data. Okay. So React will set the state to what you return from the reducer to move your state setting logic from your event handler through a reducer function in this example. Exactly, it's going to remove the setting logic from our event handlers to a reducer function. You will declare the current state in there, in your reducer function, as well as the action. Declare an action object as a second argument and return the next state from the reducer here. React will set the state to. This is quite interesting. Okay, the question is that how React is actually connecting that, because you're dispatching that, but how you notify to React that this is the action that I need to dispatch, or this is the this is the action that I need to dispatch from this reducer. Okay. So to reduce the complexity and keep all of your logic in one easy to access place, you can move the state logic into a single function outside of the component called a reducer. And a reducer are different ways to handle state. You can migrate from useState to useReducer in 3 steps. Okay, reducers are a different way to handle a state. Interesting. So you can migrate from useState as a way to now, when we're scaling application and we are now having a lot of this logic, state update logic, this way of how can we now update the memory in our components, because it can become quite harder and challenging to do that. Well, it is much more better to do using some sort of convention, some sort of way that allows to reduce this complexity using a reducer. So the reducer is another way, or is a different way to handle state. You can migrate from useState to useReducer in 3 steps. Move the setting state to dispatching action, like so. Move the setting state to dispatching action. Okay, move the setting state to dispatching actions here. Okay. Move the setting state to dispatching actions like this. All right. Remove all the state setting logic, and what you're left with a 3 event handler like this. So you move, okay, because now we're looking is at useReducer, which is a different way of handling state. A different way to handle state. And if you want to move on your logic, especially in your event handler, as the more event handler you have in that component, the way to set is the state updates, the more useful becomes to use is this reducer, is this way of reducing the complexity of looking at when this state updates. So instead of using the useState, we're going to see how can we now migrate from useState to useReducer. And that is first dispatch the actions. Okay, move from setting states to dispatching items. which I'm assuming this is something that we come there, right? And this one. Okay, so dispatch these actions. Second is write a function, which is this dispatching action is just a regular JavaScript object that follows this particular shape with the type and ID, and in the type you describe what happened, what triggered that state. Okay, and then here, then you write your reducer function that the returning action, which it takes in the, then you write this reducer function, which it takes the current state and the actions, and then it's going to return a new state out of this. And React will set the state to. The question is that how React does it set that state? Because the reducer function takes state task as an argument, you can declare it outside of your component. This decreases the indentation level and can make your code easy to read. Because the reducer function takes state task as an argument, okay, you can declare it outside of your components. Note, the code above use if statement, but it's convenient to use switch statement inside reducer. The result is the same, but it's easier to read switch statement at a glance. We'll be using them through the rest of the documentation. This is one of the ways. Say you can go with if, but let's go to stick with switch because it's more readable. So when this action.type is match one of this, change and delete and kind of thing, okay, in default throw this, we recommend wrapping each case block into a curly braces so that the variables declared inside of the different case don't clash with each other. Also, a case should usually end up with a return. If you forget to return, the code will fall through the next case, which can lead to mistakes. The TLDR is that wrap them into an object as a way to declare your variable if you need to here, and then return the new state. And React detect this. Why are reducers called this way? Also, reducers can reduce the amount of code inside of your component. They're actually named after the reduce operation, which you can perform on array. The reduce operation lets you take an array and accumulate a single value out of many. So these reduce functions, what allow you is to accumulate an initial state, and by passing through each one of these elements, apply some sort of transformations and update the accumulator, which is great, for example, when you want to calculate the total amount of, so the total price of certain items, okay? Perhaps you want us to now know is, most likely as a way to, this is very, very useful for counting, which is great, for counting. So React reducers are an example of the same idea. They take the state so far. So the function you pass to reduce is known as a reducer. It takes the result so far of the current items and then it returns the next result. Okay, it takes the result so far, and I really love the way they describe here. So this reducer function, it takes the result so far and the current items and then return the next result. Okay, but it takes the result so far, and again, all of this, this is an operation that performs on arrays. As a way to go through all of these elements into array as a way to accumulate a single value out of many of these elements on the array, and then you get something. You get one single output. You reduce the code inside of this collection. So you can even use reduce method with an initial state and an array of action. But these actions dot reduce exactly. Okay. And to get is the final state from this. So this initial state and the test reducer, okay, which is now the callback here, where you're gonna take a look at this. Hey, if this, when we're iterating through all of these actions, okay, we're going to return is this. We're going to return is this. So we're going to return is an array of this. The text and the action, the accumulator and the next element, the current element. And then you say the action type is this. So let's change and delete it. Okay. Added, change and delete it. Okay. Added, change and delete it. So for example, if one of these actions that we're receiving, okay, where initially is the initial state, which is an empty, so what we're gonna do is to return this new array from this. Okay, this is add. I want you to now take whatever you have previously and append this added here. If it is changed, I want you to now traverse to what we have so far. Exactly. So to what we have so far, okay. And now return is the action.task. But return is all of those collections whose action task has changed. Or they deleted as a way to say, hey, if this action called a delete, I want you to now iterate through that and get me only those whose idea does not match. And ultimately, unknown action, type this. So this is quite interesting example here, because you say, when you're passing the actions dot reduce, and the action is an array, exactly, and actions have this reduce function to reduce the complexity, or to reduce an object into a single output. It's this is the task reducer, the callback here that I'm going to apply, and the initial state, which is here. So for each element, you're going to check this. Hey, is this type added? Yes, it is. I want you to return what you have so far with the test, followed by the next element here, which is initially test is empty, okay, followed by this action ID, and there you got it. So I add is a new action here. Okay, if the same is true, there you got it. Then the type delete, I'm going to now run this function delete, and I'm gonna find that by ID, and get and return is this new collection without that ID, which is the ID 1, and then add the 3 like so. So the final state, it'll be now this. This is quite interesting, because when I look at this, is the way of how can we now have this collection of objects, okay? And we can is now, by passing this a callback, in this case this, by passing this a callback and say, hey, this is the instruction that I want you to do anytime we pass through each one of those elements. And I'm gonna set the accumulator here, okay? So this reducer is say, hey, I'm gonna take the results so far, which initially you passed me here, okay? I'm gonna take the results so far in the current items and returning into the next element by applying some sort of transformation logic, some sort of callback. And I'm gonna repeat that process. What is the result that we have so far? The current element, and apply is the transformation. Apply the transformation and return that. This is interesting. So you probably won't need to do this yourself, but this is similar to what React does. Oh, okay. And the output here. And then after you get that, you say output.text context. I'm going to stringify this. Find a style null and this. So now that evaluate that, it say, all right, now let me put here to output that. But when you ask, okay, okay, this is the mechanism. This is the mechanism of complete. Okay. So this is the mechanism when you update your state using Reducer as a way to say, hey, this is all. This is the state, okay? Or here is our action, okay? Here is the state updates, right? AKA our action, right? Here's the state updates, and I want you to now go over all of this and apply this reduce function, and then you're gonna return me that. So with this inner model here, so now we have a more understanding of what's going on when you actually is setting the state or dispatching an actions to a reducer. Okay. Because after all, React keep track of all of these states or all of these dispatch actions as a way to apply it to this. And then it's going to return you is the final state. But they're gonna iterate is through your actions that you dispatch there. What are the state updates? What are the actions you want to dispatch? It makes sense. And then use the reducer from your components. Finally, you need to hook up the task reducer. Finally, you need to hook up the task reducer to your component, import the useReducer hook from React. Then you can replace the useState with useReducer. And here is when now, this is how, okay. This is now how, this is now how React is, so React knows about this. Hey, this is the reducer function. This is the callbacks, and here's the initial state. Interesting. The useReducer's hook is similar to useState, so you must pass in an initial state and return the stateful value as a way to set the state. In this case, the dispatch function. But it makes a lot of sense why we need to pass this and why we need to dispatch this action. Question is that how it notify that we are dispatching an action? Do we have a trigger for that? You know, do we have some sort of function from React that expose that as a way to know if we're actually triggering the proper action? Okay, but it's a little different. The useReducer hooks takes two arguments. A reducer function, or this callback, the reducer function, this callback that are going to apply to all of, that is going to check to all of this state update or all of this dispatched action that you send, okay, and an initial state, and it returns a stateful value and a dispatch function. Okay, here's when we get the dispatch function. So this is what we're going to use here. Instead of the setter, we're going to use the dispatch function. And this dispatch function is when we pass this object in our event handlers, followed by an object with the type of indicating what happened. Oh my God! All right. Okay. So I'm not sure if this component is actually using that. You know what I mean? This is the auth reducer, exactly, but this is the auth context, auth getters, auth provider, but this is not the context. Okay. Exactly. On the context, it makes a lot of sense to define your useReducer for that. Makes a ton of sense. Map here, and the icons here, and the dispatch. But I want to take a look now at the components here. Root detail here, and of course the using is the useState for that. And a well table as well. It's like, hey, we're going to define is just use well. Hey, you're gonna render this as long as any of these row change, and that is by avoiding recomputation here, avoiding re-rendering here. You got the vendor profile, vendor header, as a way to use the context for that, which will cause is to trigger a rendering when that state change. When that state change, so you got hooks here, okay, you got page, you got plugins, interesting, query service store, and that kind of thing, as well as the components here, dialogues, component dialogues, exactly, row.comment. This is not a good pattern. This is actually not a good pattern here. This is actually not a good pattern. So on confirm and on close. And this is part of the pattern component that is handling this sharing state. As a way to say, hey, row comment and comment set. This is if you want to have much more fine control about when this component gets triggered. You know? So that's why it's like having this, the comment will never, unless you, okay. And I freaking get it, bro. And I freaking get it here. It's like on set comment, and the thing is that you are setting is that and on change here. But that's to me is quite interesting. You're causing to these components to re-render in this and apply the necessary update change. Exactly, and apply only the necessary change, which is in this case dialog context as well as dialog actions. Okay, that's quite interesting, yeah. And then you're gonna call that this actually change here. So when this change, I want you to now trigger is a re-rendering on this component that only mutate those who are using is comment. Or here. And then it's going to apply the necessary dump updates here. Yeah. All right. Okay. That's quite interesting here. Okay, as a way to say, hey, I want you to now update this, the dialog content. But it is interesting because it's like, okay, as a way to trigger is okay, state update here. That makes a lot of sense. Oh shit. Okay. So a stateful value, a dispatch function to dispatch user action to user. Okay. So here we are. Okay. So the way of how you can change your user state using a useReducer to make your state update logic maintainable is by using the useReducer that comes from React. What you're gonna pass is the callback function or the reducer function. The reducer function that will indicate what it's going to do when you trigger state updates. Okay. So what are the logic here that you're going to evaluate when you set an update state, or aka dispatch an action. And the second parameter is the initial value, where now it return is the dispatch, okay, function, where you're gonna pass is the object that actually trigger the reducer function when you set an state here. When you use this setter here from this state. Holy moly, bro. Now it is fully wired up. Here's the reducer is declared at the bottom of the component file. So he will say for exactly. So he will say, okay, instead of using the state, there's nothing wrong with that. We're gonna use the useReducer here. We're gonna pass is the logic that we want to evaluate when we dispatch an action, when we set the state, followed by the initial task or the initial value, and it's going to return you is the value, followed by a function, the setter, but in this case is the dispatcher. What you're gonna pass is the new state, this object. So when an event handler detects that, so when a user input or when the user interact and trigger an event, it will call that handler, and the handler inside of that will now dispatch is it's gonna dispatch the state updates that you register in your reducer, where this is now the state update logic here that you want to check, and then now React will say, okay, I detect a set of state. I'm going to now pass through the rendering phase, which is calling the component that actually trigger and the state updates, in this case task app. And from there, all right, now let's see if this component actually, I hold this new state dispatched here, okay, and I actually dispatch the proper action, so I can get now this state here during the rendering. And the rendering is calling your React components. It's evaluating is this React component. Yes, okay, let me now evaluate this when you, for example, change a task, okay? And that is, well, does the task state change? Yeah, it is, okay? Yeah, it is. The logic is not in the event handler. The logic is abstracted in this reducer function as a way to make it much more maintainable, okay? And perform that actions over this states, which will return this new state, okay? And then, since the task is different, now this component, because it's calling is the add on task, which is great. Actually, we don't add task. I don't think they have any more task facility or any more React component. And it's also going to call is a task list as well. Okay, where now this task list, of course, the task changed, the data that we pass in changed. So now it's not only calling this function again, okay, but also the return GSX after evaluating that task list component, it'll output is it will say, hey, do we have any more React components? Yes. All right, let's going to keep evaluating that. Let's going to keep calling them in a recursive way until there is no more component. Oh my God. And then on the commit phase, after he called all of these React components in the render tree, then he's going to say, all right, now I'm going to apply the necessary DOM updates to the DOM. So once he does that, the browser detects those changes and perform a new and repaint that. There's a lot of mechanical machinery here is going on. There's a lot of machinery here going on, similar when you have your motorcycle, because there's a lot of machinery here going on. Even in social encounters, there is a lot of machinery in there. So when we select that, okay, we are triggering is that a handle task change to this state as a way to say, all right, it'll make more sense to actually select this, okay? And on the task list, okay, and the next ID like so. So you can actually have multiple selection here. but it's thanks to the thanks to the inner logic there. It's thanks to the inner logic there. It's thanks to the inner logic there. This inner logic that is actually verifying this. It's like, hey, is this change? If it is, all right, let me now actually represent that here. And on the lower component, I'm going to now enable that checkbox for that inside of the task list. Okay, Jesus. If you want, you can even move the reducer to a different file, like this. Exactly, to a different file. Will you export that as it is? Good. Okay, but again, the entire reason of this is that we can now abstract, we can put the logic. Okay, so we can put the logic in a different place. We can put the state logic in a different place, okay? And when we need to use that, all right, we just dispatch an action, which is an object, with the proper value that will trigger that state update by returning this new state. By actually is applying all of these transformations to this state, all right? And there you got it. Reducers are not without downside. Here's a few ways you can compare that. Code size generally with useState have to write less code up front. With useReducer, you have to write both a reducer function and dispatch action. However, useReducer can help cut down on the code if many events handlers modify in a similar way. Readability. useState is very easy to read when the state updates are simple. When they get more complex, they can blob your components and make it difficult to scan. In this case, useReducer lets you cleanly separate how of update logics cleanly separate how of update logic from what happened of the event handlers. How and update logic from what happened of the event handler. Hey, what happened here on the event handler? You have now an update logic, a know-how here. Debugging. When you have a bug with useState, it can be difficult to tell where the state was set incorrectly and why. With useReducer, you can add a console log into your reducer to see every state update and why it happened, due to which action. And if action is correct, you will know that the state mistake is in the reducer logic itself. However, you have to step through the more code than with useState. Testing. A reducer is a pure function that doesn't depend on your component. This means that you can export and test it separately in isolation, which is great. While generally it's best to test component in a more realistic environment, for complex state update logic, it can be useful to assert that your reducer returns a particular state for a particular initial state and action. But again, they are much more useful to test. This is dialog. And then you're testing your component. Hey, you should have action buttons. You have disabled confirm here. Operator response, like so. Operator await row. It's the operator award rows. And here you define is this operator award rows. It renders the row with initial state closed. Renders show map car when the router is expand and hide map. When show map selection is click and map is show. Interesting. Bit progress cell speed. Vendor response. Okay. Personal preference. Some people like reducers, others don't. That's okay. It's a matter of preference. You can always convert between useState and useReducer back and forward. They are equivalent. We recommend using Reducer if you often encounter bugs due to incorrect state update in some components. But again, doing that in a very surgery way. Okay? And want to introduce more structure to its code. You don't have to use Reducer for everything. Feel free to mix and match. You can even use useState and Reducer in the same component. Writing Reducer well. Reducer must be pure. That makes sense. Similar to state updater functions, okay, where you return is a new state. Reducer runs during rendering. So when you call the components, the Reducer runs during rendering with this new state. Okay, actions are queued until the next render. This means that the Reducer must be pure, same input as always, resulting in the same output. They should not send requests, schedule timeout, or perform any side effects. They're not meant to be that impact things outside of the component. They should update objects and array without mutation. State updates by returning is a new function, so Reducer must be pure. The same input, the same output. Okay, given the same input, it will return the same output. Each action describes a single user interaction, even if that leads to multiple changes in data. Each action describes a single user interaction, even if that leads to multiple changes in data. But it describes single user interactions. So for example, if a user press reset on a form with 5 fields managed by a Reducer, it makes more sense to dispatch one reset form action rather than 5 separate set fields actions. If you log every action in a Reducer, that log should be clear enough to reconstruct what instruction of response happened in what order. This helps with debugging. Writing consists Reducer. Using now email here. User email reduction. But again, you're going to define is your callback Reducer, okay, your Reducer function. It's going to get this draft and the action. That makes a lot of sense. Change and delete and that kind of thing. And then you dispatch that. This is as a way to make consistent, exactly, for consistent update state. As a way to make it easy to update objects and arrays. Recap: to convert from useState to useReducer, exactly. To convert from useState to useReducer is dispatch actions in the event handler. Dispatch action in an event handler, write the Reducer functions, and replace the useState with a useReducer here. Reducer requires you to write a bit more code, but help you with debugging and testing. And I am all for it. Again, there's no need to actually use always a Reducer. Okay, so Reducer must be pure, which is the same input, the same output. Given the same input, you return the same output. Each action describes a single user interaction. Okay, use immer if you want to write reducers in a mutating style. Okay, this is now try out some challenge here. So dispatch actions from event handlers. Currently the event handler in the contact list, yes, and chat.js have to-do comments. This is why typing into the input doesn't work. Typing into the input doesn't work. And clicking on the button doesn't change the selected recipient. Interesting. Okay. So we got now an update issue here. So we are now perhaps updating the proper state. And we're not actually connecting to a state to our event handler. This is based on my diagnostic. Okay. Based on my diagnostic, this actually is not changing, which means it's not setting the state update. And if this input is not able to change, is that we're not connecting is the right handler. Okay. So replace this to do with code to dispatch the corresponding action. To see the expected shape and the type of the action, checks the reducer in message reducer. The reducer is already written, so you won't need to change it. You only need to dispatch the action in the context list in chat.js. So because now we got this useReducer chat and contact list here as part of the data. Or I think this is no, okay, messenger reducer. Okay, where now you have is this initial state, okay, and all of the reducers, all of this action, dispatcher actions, okay, which is type here, change selections, edit message, okay, there, okay, this is the user interactions, okay, or exactly, this is user interaction. Here we are describing is the user interaction. So far so good. So we want is to now, when we change here, we update properly this. What is this? On the contact list and the chat key. So this is now the messenger, okay, and we can take a look now at the contact list. So here in the contact list, we are receiving is this props like contact, select ID, and dispatch, which is great, okay, and we are not emitting is that event. That's what happened. So what can we do here? We can say is I would like you to now call the dispatch here, or in this case I would like now to call is the dispatch function, which is this dispatch function. Okay, I want to call is a dispatch function on click. Okay, but I want you to do now dispatch this action, and it's here we're gonna dispatch this action. Interesting. Which is now the type and dispatch the action, which is change selection on the contact list, type change selection, and what is the data that it needs to actually update the state. It pass is, so we pass is a state, okay, and an action. So we pass is a new object here. Okay. Well, here it expects you to have is the contact ID. Okay. So here you expect to have is now the contact ID. So let's do it. Because you expect that to have is the contact ID, which is contact.id. All right. So when now in this pattern, actually triggering this, okay, which is exactly we are passing is down is the dispatch to that. Okay, so we're passing is the dispatch to that. So when that happened here, so when you dispatch this, React will say, hey, who caused this component's state update? Hey, it was the contact list. It was the contact list. So we're going to evaluate the contact list here, okay, with now this new data with the contact ID, okay. This component actually dispatches this, all right, and this actually set the state with the change selection as a way to say, hey, well, let's going to return now this new state with the message empty, okay, to useReducer, which is here, to this. Okay, so now you not only dispatch this action there, you not only set this action there, which means you not only set this action there, exactly, you not only set this action there, but React is gonna say, okay, because now I trigger this, I dispatch this, which component called this? It was the contact list. But because React must know somehow which components to render, that's to me it's like not only to dispatch this as a way to change that properly, but also when it comes to the chat, we need to actually is go into the handler as a way to what's going on here. Hey, what action, what user interaction we are dispatching here? Edit message. Okay, so this chat must receive is the dispatch, exactly, and then on change, what we're gonna do is to say, all right, dispatch this new object with the type of edit message, with the type of edit message, okay, and it expect this to have from the action the message, which is the message. In our case, since we're getting is this data from the event handler, it will be the event.target.value. And now anytime we are calling this function, we are dispatching here, hey, whose component triggered this? And because they're on the same level, okay, and because they're on the same level, contact ID, okay, as a way to find that stays, okay, as a way to keep track the key here. Why is that? Because you want is to reset is the state here. You want to reset the component state by using this key here. If you don't put this, okay, so anytime you change to this, you will get is the same data here. Oh, because this must have changed is the contact ID. And it's because it changed message as well. So if we're passing now this, for example, the action.message here, in this case, when you say change selection, which is here, when you change selection, we will also now pass is this. Whose initial value is the initial state. And what is the initial state? Hello. Exactly. So now here, what's going on is that when we change here, because there are different components, exactly. So now you are able to keep that message here. But that is because the way how now this chat is being using is keeping is keeping is the same state. Okay, so if you now want to reset this component, it's like whether it's you're passing in at a different level, okay, you're passing in a different position in the render tree, or you're going to put a key to there as a way to let React know which elements are we using. The way to do this is by, let's go to find this. Let's go to find this whose state is selected, in which ID here and the state is selected. What is state? And where state come from? Okay, whose state does select ID contains that. But now here, what you are dispatching here is an object. You know, what you're dispatching here is an object. This is the state. This is the state. What you're dispatching here is an object. Exactly. So now you're dispatching is an object here. This is quite interesting. The selected ID as well. This is quite interesting, especially when you're going to select that to see, hey, is this actually match this? And when we trigger that, okay, so when we change that, we're going to also update this select ID to that. That's a way to keep track of this. So now if we want to render this or reset the state, which is the proper name, we say, okay, now I want you to is assign is a contact ID to this as a way to now reset the state of this component. Show solution. From the useReducer code, you can infer the action need to look like this. You got this, you got this. Okay, so when the user types hello and when the user press Alice. Here's the example updated to update the dispatch correspondingly. You have your reducer, message reducer, you don't mess with that, but it's in here when you dispatch this. Contact ID and the contact ID. And on the chat is when you're gonna pass is the message for that. So this is now giving you much more deterministic way, which are easy to test and debug. And reducer must be pure, and unlike state, well, you're gonna dispatch actions from the event handler, pretty much like you do with the state, but you're gonna dispatch now actions from the event handlers, write the function reducers for that given state and actions, and then replace the useState with useReducer. But it's from the event handlers that you're gonna do this. Clear inputs on sending message. Clear input on sending message. Unless we have another state here, okay, we can add as a new state, like so. Change selection, edit message. We can call this send. Currently pressing send doesn't do anything, and the event handler to send button that will show an alert with the recipient email and the message, clear the message input. So we can define now is a new user interaction in our Reducer by saying, hey, define user input, sended message. Use is the block in the case to indicate now to React, hey, we're going to return is the state, but with the message property, which what we're doing is this is string of spread here. We're saying, hey, all of the property that this object had, I want you to match this. Okay, I want you to now have this key value pair, and assign that, because this spread operator is accepting is an iterable. Something that we're gonna see that later, but this is not relevant for today's video. So after that, we're gonna do is this, and then send the message here, and trigger that event and dispatch that event on the button here. Where do we have that button? It's on the chat. Okay, so it's here we're gonna exactly edited message. On change, but on the bottom we're gonna say, hey, on change or on click. By the way, here I want us to do this. I want you to now set the alert. Are we receiving here the contact? That's right. So is show an alert. Okay. Chill, bro. I'm not clicking you. With the recipient email and the message, just contact.email. Oh my god. I'm not gonna put this here. With the contact email and the message. Okay, with the contact email here, and the message here, contact email here, and the contact message. That's one of the reasons that white TypeScript is so important here. That white TypeScript here is so convenient here. It's like, please, please. All right. Tailor undefined. But your triggering is this. That's quite interesting because it's now rendering is this. And it is calling this. Calling here. That's quite interesting here. Oh, because it's okay. It's because it's running this. No, please don't run that. Contact message. Okay. What is the name here? Initial state, contact message. Don't we have that contact message? Contact.email.
Oh, as a message. Okay. We got that as a message for it. Okay. Yeah, much better. Way much better. And then we're going to dispatch, because we're using useReducers, dispatch this action, which is an object that follow the type here, and the user interaction, which in our case we already defined that. We say send a message, but yeah, send a message. Okay. I want you to now dispatch this action of what happened, followed by now the message. Okay. So message. Period. Okay. And type send a message, and you say message. And let's go to now dispatch this. But because we are not passing as a dispatch here, okay, we are actually calling that. All right. And yeah, this is what I want you to do. Here on expect token. Oh, of course, because we need to actually is doing this in as a, we need to dispatch this as a function. Interesting. If you don't pass that, you are actually triggering that. So now, when you, okay, when you're sending a message, we dispatch here bottom, we say, hey, oh, and the message empty. Okay, exactly. And in fact, we don't need to actually send anything to the message. It's like, no. You know, it's like, no, we're gonna update the state there with this. That's all. Send that message. And then you set that. Okay. And the action type is this, and message, well, you're gonna have is this. Yep. We actually is dispatching is this, as expected. All right, dispatch the type. Only with that, no message and that kind of thing. All right. And we want this to now to dispatch is this. Oh, I think, okay, I think you stop is evaluating this. Yeah, you stop evaluating this. Yeah, but you stop evaluating that for some reason. But it's like that. Exactly. This actually won't work because it's not going to render that. Yeah, it's not going to render that. But the idea here is to putting now on click, because we already receiving is the dispatch function to set to update state. Here we need to define is the set state or our read or our action here, which is edit message. No, it's not edit message. It's not edit message. In fact, is sended message. Okay. Or you can reuse this state. Or no, I'm going to do this. It's like send that message. Okay, send that message. No, it's this one, send that message. And I want you to now return to React, okay, this new state, which is the state, previous state with the message object property as empty, right? Pretty much that. Yep. And this is what I want you to return. So state and the message. And unexpected token. Okay, okay, interesting. You expect, okay, makes sense. Okay, as a way to say, hey, I'm done. Okay, so when I send this, it's actually clean that. But this is quite interesting here, because with the previous one, dispatch actions from event handlers and clear input on sending message, we add is a new state here. Restore input values when switching between tabs. Okay, restore input value when switching between tabs. That you remember a draft for each contact separately. Restoring them when to switch contact. Your task is to change the way the state is structured so that you remember a separate message draft per contact. So you won't need to make a few changes. You will need to make a few changes to the reduction. Well, so here what we're gonna dispatch is now per context. Here is the selection entity exactly. In this example, switching between different recipients always clear the text input. So what we can do here, instead of doing this, we say, hey, I don't want to do that. In fact, I just want this to remove this, okay, and keep that as it is. Hello, hello, hello. You can, hey. Oh, but you're actually updating on the deleted message. Okay. Oh, but you want to have. You want to have per context. Makes sense. So you remember a separate message draft per contact. You will need to make a few changes to the reducer, the initial state, and the component. Yeah, because here is you want to now preserve is the context. Okay. Yeah, if we want to preserve now is the context here. Per this, I just want to okay. I want now the chat here remember this state. You know? I want now the chat remember this state. So one way to do that is by saying, hey, because I want you to remember this, we can say is message and set message here that are coming from useState with message. Okay, identify message has been already declared, so we can say is current message, to be more declarative, current message, because now I want this to have is a state. I want you to remember this. Okay, so what I can do is, well, let's go to get whatever message you are receiving as an input here, and then, okay, we will like now to, when that changed, okay, we want this to now hold the current message for that, right? Somehow we want this to now hold is the message for that. So doing this is say, okay, we're passing is the message to this, passing this message to this, and so on and so on. So we want then now is to, when we click here on the contact here, okay, I want you to now is, because this contact that after all is a state, which is the contact here is this. Okay, is a contact, is a contacts. Where in the F are we getting the contacts here? That's quite interesting. Where is contacts actually? Okay. It's actually this. Okay. One way to do this is by, I would like to now remember this. Yeah, I would like you to now remember these things here. Okay. I want you to remember is this message here. That's what I want. Somehow I want you to remember that. Okay. So it can be with the new message that I'm getting here. Okay. So far I want you to now remember that, but per context. Okay. Because we are now sharing. Okay, we are now sharing that message. Okay. So, because now we want is different context here. Okay. we will need to find is a way to now store the message per context. You know what I mean? We need to find a way to store message per context. It's like, hey, or assigning an ID to this. Hey, where this message belongs to. Where this message belongs. Hey, this message belongs to the contact ID 1 and that kind of thing. On the selection. Okay. Here we can create a map by saying, hey, now this message with the key, with the ID here. Now we will have here a map of their message, of the initial state. Okay. Because right now what we're doing is just to so we need to change the structure. So your task is to change the way the state is structured. So you remember a separate message, draft per contact. So we will need to have a separate message per contact, an object here, and a map here. Okay, where you can say, hey, this message, okay, or message, okay, it'll be now an array. It'll be now an array that contains is a selected ID and the ID, okay, on the contact ID, contact ID, okay, which will be 0 initially, and the message, okay, as a way to say, hey, this is hello. So what we're gonna do here now is that per message, okay, that per message is to send the proper message here that matches the selected ID. Okay, things are getting interesting here. Exactly, we need to have is a contact here and that kind of thing. Yeah, we'll need to have this. Okay, without having an array, what you're gonna have is this object. Exactly, it's a key value. Hey, this belongs to this and this belongs to this. So you say 0, 0. You have now the hello. 1, you have now empty. Okay, and 2, it will be is this one. So actually we are hard coding this, which is not ideal, not good, not at all. But one way to do that is by saying, hey, I want you to get me is the ID here. Okay, I want you to get me is the ID here from that. I want you to get me is the ID here. So each one of them will have its own context. So when it comes to actually pass the proper context here, we're gonna see is this. Exactly. Hey, is this chat? here. Is this message that I'm receiving here. Okay. Okay, I want you to now show this, the proper that. Okay, I'm not thinking. When the input is edited, state.message, but the change the selection context image. State.selected ID to image.id. As a way to keep. Okay. Okay. As a way to keep track is this. Alright, like this. And when you change that, instead of doing this, you're gonna have is the selected ID like this, and the message, okay, but now this message will be is that particular position, state message here, edit message, action. So okay, so we can say is hello, right? Reset this, bro. Well, somehow we'll need to find a way to actually update that, right? Somehow we'll need to actually get that. So instead of this, okay, we will have is the, okay, we will have is now the action contact here, okay, of the selected ID, of the action contact ID, which is 0, followed by it is message. Exactly, followed by it is message. So initially, of course, it will crash, because now the structure has changed. Because the structure has changed, and the structure is an object, let's say like this. So when that is updated, okay, on a component, instead of actually points to here, we want is to now reset this state, and in our dispatch here, in our chat, we need to actually say is message on that position state.message, state.select, okay, state.select ID on change on edit message. On edit message, you want us to now set that ID. State that ID in the action here. state that I selected ID does the action message. Okay. Yeah. No, no. Again, I'm not dedicating time to this. Well, that'll be all for the video. Take care. Bye bye.